Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is your MCQ and the question is in front of you. Which of the following is most stabilized carbocation? I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's now question. Which of the carbocation is most stabilized? But if you look at carbocation, all carbocations are 6 electron species. Why? Because if you look at here, there are 2 hydrogen. How? These 2 hydrogens are bonded with sigma bond, and there are 3 sigma bond, and each sigma bond carry 2 electron. So in total, the outermost shell of this carbon in this compound, this carbon I'm talking, is carrying 6 electrons. So you can say, sir, carbocation is actually electron deficient, and you may say it's an incomplete octet or sextet. Means any electron donating group or any electron donating effect can stabilize, like inductive effect, hyperconjugation, and resonance. Now if you look at here, this carbocation, it is student allylic with respect to this region and primary. So it's allylic and primary. Now if you look at here, this one is actually tertiary but not allylic. Now if you look at here, this is allylic and tertiary. And by the way, if you look at here, it is actually allylic with respect to both of the double bond and tertiary. So if you think that, sir, where the electron donation to the carbocation is maximum, obviously here. Why? Because here one allylic. So by the way, how allylic carbocation is stabilized, if I say, so if you consider this part is R, so you can say R, there is CH2 double bond, and the positive charge student comes here, means there is a CH3, the positive charge is here. In this way it is resonance stabilized. Now tertiary carbocation case, actually 3 plus I effect and hyperconjugation, means 3 plus 2 5 plus 1 6 hyperconjugation possible. Now if you look at here, it is actually tertiary and allylic, similar. Now if you look at this is little special, it is tertiary and allylic with respect to both. So let me draw this side canonical form, you can understand very well, but how this side is. So actually one canonical form could be, it will come here and this. So now you may think positive charge is now here. Now what another stabilization possible, that is the lone pair of oxygen can participate. So what canonical form I shall get here, there is a OMe, one lone pair gone, so there is a positive charge, and these are everything like this. Now you may say, sir, oxygen is a electronegative atom, it is carrying positive charge, really stable. In this case student, it is stable. Why? Because if you look at, if you draw the resonance, every time this positive charge is going somewhere, for example it was here, after that positive charge came here. Right now this carbon is actually 6 electron species, but if you do resonance with the involvement of these oxygen lone pair, you can clearly see that these oxygen is also 8 electron species. How? This oxygen has one lone pair, 2 electron, bond with one methyl, 2 electron, 4. This is a double bond, 4 plus 4, 8. And all other carbon atoms in this molecule is also 8. So in this structure, you can conclude, student, all atoms, means carbon and oxygen I'm talking, are octet filled, means stable. So that's why. Now here the stabilization is maximum, so option D will be the right answer. And remember one statement, higher the delocalization of charge, it could be negative, it could be positive, higher will be the stabilization, and that is obtained in case of D. So right answer is option D. Whether if you get this question in your exam hall, less than 30 seconds you can solve. First of all, you need to understand that okay, this is primary allylic, this is tertiary but not allylic, resonance is absent here. So okay, confused. Now if you look at it, this is allylic and tertiary. So with respect to option C, option A and option B gone. Now compare option C versus D. Okay, this side is there, additionally one extra stability. So this is the answer, this is also one. Very quickly you can get the right answer, but you need to do some practice. So in conclusion, what you have learned today, that carbocations are electron deficient species and electron donating groups helps to stabilize these cationic species. Here inductive effect, hyperconjugation and resonance are the electron donating effect, and among them resonance is most powerful to stabilize carbocation. Now remember the third point, oxygen is actually an electronegative atom. So positive charge on oxygen means, positive charge means deficiency of electron generally. So positive charge on oxygen could stabilize the carbocation. Say positive charge on oxygen you may consider really stable, sir. Yes, if it resulted octet field structure. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.